Question number 2, and this one is based on probability. So two events A and B are such that P of A is equal to 0.65, the probability of A is 0.65, the probability of B is 0.45, and the probability of A union B is 0.85. So first what I would do over here is I draw a Venn diagram, because they're obviously talking about A, they're talking about B. Now they've said that this is A, this is B. They said probability of A union B, that means the probability of both of these combined is 0.85. So that means the outside must be 0.15. Because in the end, everything added up in this circle has to be equal to 1. Everything has to be equal to 1. Right? So if P union A, this entire part, is 0.85, that must mean that the outside is 0.15. Now they said P union A is 0.85, and PA and PB are the values are both given over there. So to find, you have to find over here, you have to find the intersection. You have to find the intersection, which finally gives you that value. So we know that there's a formula for P of probability of A union B. Probability of A union B is the probability of A plus the probability of B minus the probability of A intersection B. So that means probability of A, this entire circle, plus the probability of B, so this entire circle, minus the probability of A intersection B. That means this part over here. That gives you probability of A union B. So we just plug in our values here, so you get 0.85 is equal to 0.65 plus 0.45 minus PA intersection B. So after plugging all this in, you bring this over to the other side and you solve for P of A intersection B, and you should get the value of 0.25. Now let's do the B part. B part is find P of what is this? A semicolon dash B semicolon. So this is a little bit harder over here. So this basically means that they're asking over here, you have to use a theorem that's given in the formula booklet that you have. The theorem is called, let me try to remember this. Yes, it's called the Bayes theorem. Bayes theorem. So in Bayes theorem, the rule is if you have any values like this, the rule is that they're basically asking, this value over here that you're trying to find is basically whatever I'm writing here. So A dash intersection with B dash over probability of B dash. That is how you find this value over here. That's what this dash implies. It's in the formula booklet, and this is the rule that you use over here. So we know we have these values over here, and basically probability of A dash intersection B dash, I just want to make this clear, is basically everything but this part over here. That means this part we do not include. P of A dash intersection with B dash is basically everything but this. That means everything on the outside. So all of this is what we include. This is what we want when they ask that. So that means that our value is 0.15. So P of A dash intersection B dash is 0.15. And probability of B dash, which is everything but B, right? Everything but B is this part over here and this. So if you solve for that, you should get that value as 0.55. So that is 0.55 down here, and that is equal to 3/11 once you simplify. I want you to keep it in this form because this is the form that I kept it in. And I'm pretty sure this is the form that the mark scheme kept it in, because you do not have a calculator and you can't find out what 3/11 is. So I keep it in this form.